So welcome to this talk on the future of machine learning and JavaScript. My name is Asim Hussain. You can find me on Twitter as Jawake, not Jawashe, Jawake. I blog about Angular and JavaScript and other things on my website, codecraft.tv. And I recently bought asim.dev. There's nothing there yet, but I will soon have a website, hopefully, once this thing goes on to YouTube. I'll have a website there as well. And I'm also what's called a developer or a cloud advocate at Microsoft.com, at Microsoft. So we are the cloud advocates, the cloud developer advocates. We are the open source advocates. So we work inside the Azure cloud platform, and we advocate for Azure, and we also advocate for open source technology. So my specialty, my area of expertise is JavaScript. But if you go to this link, you can find all the other cloud advocates that we have in our organization. And if you need to ask them anything about Azure, anything about any of the open source technologies that they represent, then please just go to this website and find out who they are and connect with them. So I have an interesting story. So we arrived in Belgrade last week. We had a little bit of a family holiday. And this is Katerina and Goran. Goran, are you here? He mentioned he might turn up today. No. Okay. This is Katerina and Goran. So a few hours after arriving in Belgrade, when I finally opened up the luggage in our Airbnb, I realized it wasn't our luggage. It was somebody else's luggage. At exactly the same time, my wife, Jeanette, shouted down from the bedroom, "Somebody's contacting me on Instagram saying that we have their luggage." I was like, "Huh? Yes." And that person, in fact, was Katerina in the corner there. And this is what it was. Basically, on the left is my bag, and on the right is their bag. So we had exactly the same bags. I bought these bags 10 years ago. I have never met anybody with these bags, and I travel a lot. But this one day, we find somebody who had the same bag. And how they found us, I think, is a really interesting story. It's got nothing to do with machine learning and JavaScript, though. But I'll just tell it you anyway. So basically, this is the tag that was on the bag. It was actually my wife's name was on the tag. And one thing you should probably notice about that is her name is spelled differently to my name. Mine's Hussain. Hers is Hussaina. So Katerina first looked at the baggage tag and then started Googling Jeanette Hussaina and couldn't find anybody. So she thought it was a misspelling. Actually, what this is my wife's Latvian. And when she married me, she took my second name. But in Latvia, you have to Latvianize your names. So they thought 2 S's is too many S's. You don't need 2 S's. You just need 1 S. Efficiency. So they said Hussain. And you have to, the names have to have a gender. So Hussaina is the female form of a name. So anyway, that's why she couldn't find Jeanette Hussain. But then she thought, hang on, why don't I just search on Instagram to see people who've tagged Heathrow Terminal 4. This is the airport that we left. And if you look in the top right-hand corner, we had tagged and posted an image to Instagram because it was little Micah's first trip. And so then she clicked on my wife's Instagram, and then she found this photo, and then basically I'd rented a houseboat, and I think I successfully rented a good property because my wife immediately took a picture and posted it to Instagram, and the picture said Sava River, Belgrade. So Katerina knew instantly that this was the right person, and then she contacted Jeanette, and everything was fine. That whole process took her just 25 minutes. And 15 of those minutes, she was searching for Hussaina. So as soon as she figured out, she took 10 minutes to find me and message us on Instagram. There's a lesson here. My first reaction was quite negative. I was like, oh my God, look at how much information we're releasing on the web publicly about us. Somebody could find me in 10 minutes. And then my wife, ever the optimist, said, this is amazing. Because of the information that we released out there in the public on the internet, this person was able to find us and swap our bags. I'll let you decide what the lesson of the story is. But that's just a little quick story about our journey into Belgrade. I'm also work with a charity called the Palestinian Internship Program. And what they do is they find Palestinians, recent Palestinian graduates, internships in high-tech Israeli and Palestinian startups. I helped mentor a number of the interns last year, and this year I'm very, very proud to say that of the 17 tech interns that we've got through the program this year, every single one of them has one cloud advocate from Microsoft mentoring them throughout their process. So if you are somebody who works at or with an Israeli or a Palestinian startup and you are looking for interns, contact me, go to the Palestinian internship program, I can connect you up with the right people. Anybody here heard of Udemy? Excellent. Anybody here my students on Udemy? No, 2 hands. Excellent. Fantastic. So Udemy added in automatic subtitling to the website, to the videos last year, and they correctly transcribed my name to awesome. So my name is Awesome. And you can think about me over the last year, I'd say, is this. So this is a famous meme. So this is actually not my slide. This is my friend Eleanor Haproff's slide. So Eleanor and I go back a long way. And she's into JavaScript and machine learning. I'm into JavaScript and machine learning. And then last year, we decided, oh, why don't we, this is something interesting is happening in this space. We were in the edge of it, and we could see something was happening. And we thought, why don't we create a meetup group? And that's what we did. So we created a meetup group in London called AI-JavaScript. It's growing very, very fast. There's been a lot of interest in the space. And then over the course of last year, people, because we were in the space of AI and JavaScript, they kept on sending us links to JavaScript applications which had some machine learning, which had some AI aspects to it. And we thought, actually, why don't we put all those examples? These are great examples where people can learn. Why don't we put them somewhere? And so we created a website called AI.js Rocks. Okay. So if you go to this website right now, you'll find lots and lots and lots of different examples of JavaScript-powered applications that demonstrate some feature of AI or machine learning or something along those lines. Every single application that has to exist on there, to exist on this website, it needs to be something you can click on and play around with in the browser, and also something where you can view source, or you can see the GitHub, and you can understand how it was built. So it's more a learning resource. And today's talk, what I'm going to talk about, is 3 different applications that you can find on AI.js Rocks. I'm going to explain to you how those applications work, and I'm also going to explain to you a little bit of how they were built. And so you're going to learn through the course of these 3 example applications, you're going to learn a little bit more about machine learning and a little bit more about machine learning and JavaScript. Till the end, you're going to have an idea of where the world is these days. Okay, so the first application, the Emojifier. It's actually mine. I built this one. It's not trademarked. It's just the Emojifier. So I thought that would be a funny little thing to put at the end. And what it does is pretty amazing. It can take, you can give it any image with full of faces. It will detect the different faces in an image. And any guesses what it would do then? Any guesses? Correct. It emojifies it. So what it does, it detects then the emotion in the face, finds the correct emoji, puts it on the face, and puts it back on the image. That's what it does. Elon Musk, watch out. I'm here. So you can actually go to, if you go to themojifier.com, I created this as a Slack bot. You can actually go to themojifier.com, click Add to Slack, and you can actually add this to your own Slack workspaces in your own workplaces. And what it does is this. It's very, very simple. You can do /Mojify. Oh, there's my son. Some of you saw him before. You can do /Mojify, image, and yes, that is his emotion right now. Also, it can handle multiple faces. There you go. Seems quite accurate as well. And I've managed to finally answer this question that has plagued artists for hundreds of years. There you go. That is actually the Mona Lisa smile. So there's lots of different parts that's involved in this application, lots of different things that it does. But I think the most interesting part that it does is how does it calculate emotion? Emotion. How would you figure that out? And it turns out it's actually really, really simple. Very, very simple. It just has 2 steps, okay? First step is you need to detect the facial features. So this is kind of a well-known problem these days. We know a defined set of points on a face. If we can capture all those points on every single face that we can find, we know what the features are. Okay? And there's lots of different ways of getting that. There's lots of different algorithms for getting that. And there's lots of different JavaScript libraries as well for finding the facial features of a face. So that's just step 1. You need the features. You need to know where the eyes are, where the nose is, where these things are. You need to know where they are. That's step 1. The second step is also really, really easy. You just use a neural network. Okay, so those are just the 2 steps that you need. Do you need me to explain neural? You need. Okay, for my son, he's a little bit young. He doesn't quite know this quite yet. Okay, I'll explain what a neural network is. So a neural network has a basis in biology. This is a neuron. You should have at least one of these. Maybe a few less after last night. So it has some dendrites going into a body and some axons going out. If enough electricity flows into the dendrites, the body activates and pumps some electricity out of the axons. That's it. If you stick a couple of billion of these together, you get a human brain. I think it's a few billion. I don't know exactly how many it is. But you get a human brain. I personally think there's a little bit more to consciousness than just this, but it can achieve a lot. If I asked any of you to code this up using your favorite programming language, you'd probably build something like this. You'd have some nodes, some edges going into those nodes, and some edges coming out. And then you get some features to pump in, some values to pump in that you want to make some determination about. Maybe it's number of coffee shops in a district, house price increases over 2016. This was a study done in London. The more coffee shops, the greater the increase in house prices. Interesting, yeah? And then what you do, you create one of these neurons, then you basically randomize some numbers, and you assign them to the edges. Then all you do is you multiply them together, add them up, and pass them through something called an activation function. And then whatever that activation function returns, it's just a function. You pump that out, and you connect that to another one, and another one, and another one. That's it. Just explain a little bit more detail with a slight animation. That's it. That's all we're doing here. Doing a little bit of multiplication, a little bit of addition, passing it through a function. That's all that there is. When I teach a machine learning workshop, and there's always a partway through the workshop where somebody goes, "Is this it?" It's just multiplication. Yeah, for the most part, multiplication forms a large part of what you do in machine learning. It is as simple as this. The activation functions, you can have many, many different types, and the choice of an activation function is important. But this is a very, very simple one. Anything below 0 is 0. Anything above 0 is 1. And then you put a bunch of them together into a neural network. And this is one with one input layer. It's very difficult to do this backwards. Hang on. One input layer, one output layer, and 2 hidden layers. That was very poorly done. 2 hidden layers in the middle. And then what you do is you randomize those weights on each of the edges. You just randomize them, random numbers. That's all you're doing. And then you get your data set, the things you want to train on. So for us, it's going to be a set of images, which a human being has already gone through and said, this is a happy image, this is a sad image, this is a happy, sad. You grab the facial features, the points on the face. Maybe these are the input values for those points, whatever they are. You pump them into your network. It multiplies everything out, and it gives you a number at the end. You've decided, you believe that it's giving you 3. But is 3 right? Like, we know because we've looked at this image that person, the value is 8. Maybe 10 is happy, 0 is sad. We think this person's 8. So this network is wrong. It's wrong. It's off by 5. And that's good. We need to know how wrong this network is, and then we take how wrong it is, and we do something called backpropagation, and all that does is it tunes those numbers. Of course it's going to be wrong. It was a bunch of random numbers at the start. What we then do is we pass in data, we figure out how wrong it is, and then we use this backpropagation algorithm to tune those numbers. We keep on tuning that. We pass in the data again and again and again and again, and we tune again and again and again until it gets better. Until eventually it gives you the number that we want. That's it. That's a neural network. That's how you would basically code up a neural network. There are data sets out there where people have open data sets that you can use for free, where people have categorized images across a range of emotions, and you can train your own neural networks to detect emotion. But some of these problems, this is actually a very, very, very common problem. A lot of people have this kind of problem. So there's a number of different companies out there that have taken this data, make it available via an API to you, and so you can use. One of those companies is Microsoft. Well done, my wife. So one of those is Microsoft. So we have a bunch of these APIs available on what's called a cognitive service. This is one is called the Face API. And I'm always very annoyed with this image because this is, in our marketing image, we have somebody who looks very confused as a background image. It's not confusing. It's very easy to use. All you have to do is make a post request to this endpoint with an image to with a path to a URL, and it returns to you a whole bunch of data. This is only a subset of the data. It returns you a whole bunch of other information about the image as well. So it returns to you for each face in the image, returns you the position of the face, and it also returns you the emotion: anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. Anybody here with a beard? I see one person there. Anybody else with a beard? Quite a few people with beards. I'm afraid you cannot be 100% happy if you have a beard. I've only ever reached 99% happiness, okay? 0 is the least of that thing, 1 is the maximum of that thing. And that's all I used. In the Emojifier, I grabbed the appropriate emotion, matched it to emoji, and put it back on there. So just to summarize, neural networks are incredibly powerful. If you've been doing any stuff with machine learning in this space, this is where all the advancements, or most of the advancements in machine learning, have really come in the last kind of 6-7 years with neural networks. But conceptually, they're very simple to understand. I mean, that was a very, 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 very basic example, but you got a very, very, very basic example in 5 minutes. There's very, very little you can do in tech these days where you understand the basics of it in 5 minutes. There you go. First application done. You should all have a grounding in neural networks now. Let's move on to the next application. So, I don't know if you can see, my T-shirt says something here. It says, puppies, Azure, and I'm fine. There's a long, long story behind this T-shirt. I'm not going to explain it. But basically, I was giving a workshop on machine learning one day in London 6-7 months ago, and I was wearing this T-shirt. And somebody called Oliver, one of the students, later on then created this demo and sent it over to me, and I thought this is a really good demo. He called TensorFlow MobileNet, and I'm fine. And what it does is it does an API request to a service called Unsplash, gets you an image. So you search Unsplash for puppies, gets you the first image. Then it tells you in the bottom left-hand corner what it thinks is in the image. So it thinks there's a fur coat, thinks there's sunglasses. It's not very good. No. Platypus, duck-billed, platypus is not that good there. Searching Azure, could be a fountain, maybe, don't know. Okay, here we go. A dog, 9% a dog. And, okay, so it's not very good. I didn't say it was a good demo. It's a demo, okay? But the important thing about this demo, the thing to realize about it, is that the only API request it's making is to unsplash for the image. The detection of what's inside the image is happening completely in the browser and in JavaScript. Okay? It's using a technology called TensorFlow. Put your hands up if you know TensorFlow. Put your hands up if you use TensorFlow. Ah, a few hands. Excellent. So TensorFlow is a technology released by Google in 2015. It's used for a bunch of things. Well, it can be used for a bunch of things, but the main thing it's used for is machine learning. The main thing it's used for is machine learning. And it helps you take mathematical operations involving tensors, which are multidimensional arrays, and do lots of calculations across lots of computers or across lots of GPUs, and lets you scale out these calculations because you need to do a lot of number crunching to do machine learning. And it's written in kind of C. It's a very heavyweight application. But last year, almost just over a year ago, in the TensorFlow Dev Summit, they released TensorFlow.js. Here we go, TensorFlow.js. So the JavaScript version of TensorFlow. Now, the first thing I thought when I heard about TensorFlow.js is I thought it was bindings to TensorFlow. I thought I needed to install TensorFlow. Remember, it's a C, it's a full, heavy application. I thought I needed to install it to use it from JavaScript. No. TensorFlow.js is a complete rewrite of TensorFlow in JavaScript from the ground up. The browser version of TensorFlow.js is a complete rewrite of TensorFlow from the ground up. Why is that important? It's important because of this. Because now, if you want to do machine learning in JavaScript, in the browser, this is all you need to do. If you're a proper JavaScript developer, you do an import statement at the top. If you're like me, script tags at the bottom. But this is it. This is the only dependency that you need. Just one JavaScript file, and you can start doing machine learning in JavaScript. Simple. You can do a bunch of things with it. You can do training. So the thing I showed you before with the different nodes and the backpropagation and the loss functions and the tuning of those weights, you can do that. You can do that with TensorFlow.js. It's fine. Just the same way as you can do it with TensorFlow. But the other really cool thing about it is you can load pre-trained models. So models that have been trained up somewhere else, perhaps over hundreds or thousands of computers, and saved somewhere as a JSON file. You can actually load them up in the browser and use them in something called inference mode. And that's actually what Oliver used. He used a model called MobileNet, which has been trained up previously. It can detect 1,000 different things in the world. That's why it wasn't very good. It can only really detect 1,000 things in the world. But these models can actually be very, very, very large. So what they did with MobileNet was optimize it so it's small enough that it can be used on mobile devices or downloaded from the browser. Still pretty large, actually, but it's small enough now that it can be loaded and used from the browser. You would tend not to use MobileNet to detect things in images. You tend to use it for something else, which I call transfer learning, which we don't have time to go into today. It was a very, very exciting field in this space. And that's what he used. But you saw wasn't very good. Was not very good at all. Okay? And that's because it's been optimized for size. If you really, really, really want to know what's in an image, what's going on inside there, you need to use a much, much larger model that's been trained up intensely. And these are things you can't really download in the browser, but you can use from Microsoft. Excellent. Well done. You get a sticker. Seriously. There she is again. Very confused. So we have something called the computer vision API. Okay, you pass an image and it tells you what's in the image. It can tell you a lot about what's in an image, a lot about what's in an image, but what it can also tell you is a caption. It can actually tell you in a sentence, in a human-readable English sentence, what's in the image. So my colleague Sarah Drasner thought this would be a really cool thing to do for websites for accessibility. What we're supposed to do with websites is when you add an image tag, in the alt attribute, you're supposed to write the description of what's in the image. So somebody who can't see the screen reader will read out the description of what's in the image. Not many people do it properly. So she thought, wouldn't it be great if you use this service to automatically generate the captions, put it in the alt tags? And that's what she did. So she created a little demo of that. So this is just, you can try it yourself. It's on a code pen. And the text at the top is the caption the API returns. So this is the image. It says, a black and white photo of Thomas Edison. The text says, hey girl, did we just share electrons because I'm feeling a covalent bond? I don't know what that means. If any chemists there's no chemists here, because apparently, or physicists, you'd all be laughing. But I don't know, I don't really get it. But the thing I was amazed about that, and remember, the text is generated by a computer. The thing I was amazed by that is it didn't just say a black and white photo of a guy. It knew this is Thomas Edison. It knew this was Thomas Edison. And it actually also knew to take the text from the image and it was relevant in a caption. Okay? But even this API gets it wrong sometimes. And some very, very helpful people on social media pointed out. There's very helpful people who tell you you're wrong all the time on platforms like Twitter. They're very helpful. So this is a very helpful person said this. So he said, oh, this says a star-filled sky. The text says 4 something. Okay, didn't work out quite well then. The next one, I think we could be right. I mean, you don't know. Those could be dead stuffed cats, for all you know. I really like the next one because I think we're half right on the next one, half right, and 50% is pass where I come from. A man and a dog posing for a camera. 50% right. Not bad. So just to summarize, and if there's one thing you should take away from this talk, it's this one, which is that, TensorFlow.js doesn't have any dependencies. It doesn't have any dependencies. You don't need to install TensorFlow to use TensorFlow.js. It's completely rewritten from the ground up. So it's a very, very, very easy way to get started with machine learning if you're a JavaScript developer. And also gives us a way of doing, gives a JavaScript developers a place in the machine learning community. Yeah. I always start off, when I'm teaching this stuff, I always get people to start off with a little bit of MobileNet, because it's very, very easy to get started. You dip your toe in, it's a quick start. But it's not very good. So if you really want to do any kind of image analysis, you probably need to use an API. If you want to do it quickly, you probably use an API like ours, the Azure Computer Vision API. Okay. Last demo, my favorite demo. Actually, let's just watch it. The next animation, the next video you're going to see is being run in the browser. Okay. So you can draw the outline of a cat, and it will fill in the rest of the cat. Beautiful cats. It will fill in the rest of the cat. Okay? This is it's pretty scary, but this technique is excuse me. This is using an algorithm called Pix to Pix. It's an implementation of an algorithm called Pix to Pix. And what it does is it uses a technique called a generative adversarial neural network, a GAN. Okay, it's a pretty new technique. It's only been around for about 2-3 years now. And what it does is it uses two neural networks which compete together. This is why everything's going to make sense now, why I explained those things all the way to this point. This uses two neural networks that are competing with each other. One is the generator, and one is the discriminator. The generator's job is to take an outline, an image of an outline of a cat, and generate images of cats. But remember, I told you before, when you start these things off, when you initialize them, they're initialized with random numbers everywhere. So it's not going to do a very good job of generating cat images. It's probably just going to look like noise to begin with. You take all of those, you get a whole bunch of input outline images. You generate wherever the generator gives you, you take that. And you combine it, or you mix it, with a set of real cat images, real ones. Mix it together like a card, you're shuffling a deck of cards. And you pump all of those into the discriminator. Now, the discriminator's job is to be able to tell the difference between a real cat image and a generated cat image. That's the discriminator's job. So the discriminator is also not going to be very good. It was initialized with random numbers. It's not going to be very good. So initially, it's probably going to get it wrong. It's going to go, that real cat image, that's not real. Oh, the generated cat image, that's real. It's going to probably get it wrong. And when it gets it wrong, it does that thing I described before, backpropagation. It tunes those values to become better. So it knows it's wrong. We know it's wrong, so we tune the discriminator. We just tune those values so it gets better. If it got it right, then the generator's not doing a good job. Because the generator needs to be so good that it's generating real cat images. So then the generator is tuned to become better. And that's what happens. You go again and again and again, and the generator gets better, the discriminator gets better, the generator gets better, the discriminator gets better, and they both compete with each other and are fighting each other and both getting better and better and better and better. Until eventually, the generator gets so good at generating cat images, the discriminator can't tell anymore. It just can't tell anymore. And at this point, you know you're done. You're done with training. What you do is that you get rid of your discriminator. We don't need that anymore. And we just take the generator. And you remember you could export that. You could save that model as a JSON file and then load up in TensorFlow.js and use it in the browser. And that's what they did in the demo. And you can basically draw a new cat image, and it will generate you a cat image. Okay, that's how it works, all right? But who cares? It generates images of cats. What's the point? Why is that important? Well, maybe this will make it a little bit more, bring it home a little bit more. The images on the left, the outlines, those are the inputs. The images on the right is the outputs. So those things that look like real images of women are generated by a computer from input outlines. But this isn't the pix-to-pix algorithm. This is the vid-to-vid algorithm. Okay? This can't be run in the browser yet. Okay, but this is working. You can do this right now. So this is generating a video based on some outlines. This maybe is a little bit more intriguing. One input, multiple outputs. It's a little bit more scary, isn't it? But the input doesn't have to be outlined. You can train these GANs up using anything as an input. Anything at all, okay? You can train up using segmented images. So these aren't outlines. It's kind of an image which has a color which denotes depth, okay? It's segmented images. And then you can do things like this. So she's not dancing. Those images are generated from those images. You can actually look, you can see the hands, if you look close, the hands look a bit weird when it's just there. So it's a generated image. How about this one? So this segmented image of a scene on a road. Different objects are being colored a different way. And these are 4 different algorithms. The top right is pix to pix. I can't remember what that is. And this is vid to vid again. This is generated from that. You can tell a few different things, that there's a blob coming out of the car, but it's pretty impressive, right? You don't even have to put as an input. The input doesn't even have to be an image. The input can be anything you want, anything. The input can be text. Text. So the input into that whole program is text. The output is an image. So the text at the top is, the flower has long, thin yellow petals on lots of yellow anthers in the center. That's the input that you give this thing. You don't draw an image of a cat, you give it text. The top line is after 600 iterations. The bottom line is after 1,200 iterations. Pretty good. Pretty good. Oh, that one's a bit weird. But the rest are pretty good. The bird is white, black, and brown in color with a brown beak. I think all the ones are pretty good apart from this one here. This one's a little bit weird. But if I drew an image like that of a bird, you'd probably all be very, very impressed. I'd be very impressed with it. That's generated stuff. How far away do you think we are from somebody typing into a form, an e-commerce website with 14 pages, contact form, bluish, go? I don't think we're that far away. Not that far away at all. Just to summarize, so GANs are used to generate new things. They're generative. That's what's so exciting about it. They can create new things. Whereas a discriminator, all the discriminator can do is discriminate between things. The generator can generate new things. They take a lot of computation to train. So you can do GANs in JavaScript, but you can't do GANs like these in JavaScript. You can just do demo things in JavaScript. But the generator model can be optimized to run in the browser. So that's what they did. So it generated it with the cat one when they trained it. It's still about, you can have a 15 megabyte version or a 50 megabyte version if you look at the website. Small enough, though, that you can start looking at running in the browser or running on a device. That's it. If you want to learn more, especially if you want to learn things like how to build the Mojifier yourself, you can go to that URL, and I wrote a tutorial step by step. So you can create a Slack bot and add AI features to it. So it's pretty cool. Or that's also where you can go, or if you want to go to actually add it to your Slack, it's themojifier.com. And that's it. Thank you very much for your time. My name's Asim Hussain. You can follow me at JoelAke. I can wait. Sorry. Okay. Oh. Is that time? Is that Q&A? Or what do I do now?
If you want some questions, answers. No?
Yeah?
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 Or no? Yeah.
Sorry. First of all, nice presentation, really, but I didn't catch that you point out what's the advantage of training a model in the browser, opposite to training the model on the, for example, some cloud-based service or something that.
Yeah. No. Yeah. Great point. I don't think I mentioned that actually. That's a really good question. So yeah. So I'm not. There are use cases for training in the browser. But a large part of this is now, especially with tools like TensorFlow.js, you can now train somewhere else because a lot of these models require a lot of computational power to train, save them, export them into a format which can then be loaded up in TensorFlow.js, and then you can use the models in the browser. So the way to think about the browser is as an edge device. So something where you can use trained models. There is use cases for training in the browser, and that's something I don't have. I should probably do a whole talk on that myself. Where's my son? Okay. I lost my son, apparently. There's a use case for training in the browser, and I think it's a very exciting use case. It's called transfer learning. Have you heard of transfer learning? Yeah. So with transfer learning, you take an existing model that's been trained up on the server side, and what you can do is the way to think. It sounds horrible. Lobotomize. You know the word lobotomy? We used to do it. We used to kind of like go and like strip out parts of people's brains because we thought that's how that would help them. We would strip out parts of their brains and then kind of retrain them. And that's what you can do. You can take an existing model that's been trained up somewhere else, strip out the final few layers, and then you can start from that. It's kind of like, imagine training up somebody from scratch to be a JavaScript developer versus taking a Python developer and retraining them into JavaScript. That retraining, it's possible to do in the browser. Possible to do in the browser. Yeah. Any other questions? There's one over there.
Hello, the question about training. In the TensorFlow in Python, we can set GPU or CPU mode. What about JavaScript?
So in the browser, because the browser uses GPU, it uses GPU mode all the time. There's a Node version of TensorFlow.js we can use on Node. And if you want to use CUDA, if you want to use some of the other kind of GPU mechanisms, you have to it's a little bit trickery. You have to install some extra modules, but you can use GPU on the Node.js side. The one thing I will say, I didn't mention this before actually, but TensorFlow.js, when we're running the browser, is TensorFlow rewritten as JavaScript with a subset of the operations, so it just works there. TensorFlow.js run as Node.js, if you know Node.js, then it is bindings. So when you actually look at what happens when you install that, it installs TensorFlow, the library, and then the JavaScript is then just interacting with TensorFlow the same way you might interact with it in Python. So you can do pretty much everything you can do there in the Node version. Does that answer your question? Awesome.